It's pretty clear we're all drowning in data. But here's the thing, more data doesn't automatically mean more clarity. In fact, it usually means the exact opposite. So today we're going to fix that. I'm going to walk you through a simple but really powerful framework that top consultants use to cut right through the noise and turn that data overload into decisive, confident action.
So here's our game plan. First, we're going to uncover the one big idea that makes all of statistics way simpler. Then, we'll dive deep into the two essential toolkits that every single data analyst needs. After that, we'll figure out exactly how to pick the right tool for any problem you're facing. And finally, I'll leave you with one key takeaway that you can start using like tomorrow. Sound good? Let's jump in.
All right, first stop, the big picture. Before you even think about opening a spreadsheet, you need a mental model, right? We're going to build a simple, clean framework that can handle pretty much every data problem you'll ever run into. This is all about thinking methodically.
Does this feel a little too familiar? You've got spreadsheets, dashboards, reports, they're everywhere. You have more data than ever, but when it's time to make a big call, it still feels like you're just guessing. This is the exact problem we're going to solve today. How to turn that ocean of numbers into a clear, compelling story.
So let's start by totally redefining what statistics is. I want you to forget that dry academic stuff you might remember from school. For us, let's think of statistics as a practical science. It's just a set of tools designed for one thing, and one thing only, to help you make better, smarter decisions by making sense of the numbers.
Okay, now here is the secret. The whole seemingly complicated world of statistics, it can be boiled down to just two fundamental toolkits. That is it, just two. This is the absolute key to cutting through all that noise. Every single statistical method you will ever hear about fits neatly into one of these two buckets. Once you understand the difference, you'll have a clear path forward for any analysis.
And here they are. On one side, you've got descriptive statistics. This is all about answering the question, what has happened? It's looking backward to summarize reality. Then on the other side, you have inferential statistics. This helps us answer what might happen. It's looking forward, using data to predict, to forecast, to make educated guesses. Past versus future. What we know for sure versus what we think is probable. This is the single most important distinction.
Okay, let's pop the hood on that first toolkit and see how it works. We're going to unpack descriptive statistics. I want you to think of this as the art of painting a super clear, accurate picture of the data you already have.
So what is it really? Well, it's the art of taking a huge data set, like say all your sales from last year, and just summarizing it. The goal isn't to guess anything about the future. It's simply to describe the main features of the data you already have in a way that's totally easy to understand.
Now this is where it gets interesting, because this tells us how we do it. We describe data in three main ways. First up, measures of frequency. This is the easy one. How often does something happen? We're talking basic counts and percentages. Second, measures of central tendency. This is about finding that one typical number, like the average or the median, that can represent the whole group. And third, measures of dispersion. This one's crucial. It tells us how spread out the data is. Is everything clumped together, or is it all over the map? That's where things like range and standard deviation come in. You put these three together, and boom, you have a complete 360-degree view of your data.
Let's make this real with a quick example. Imagine a supermarket. They just want to understand their daily milk sales. They're not trying to predict tomorrow's sales yet. They just want a clear picture of what happened yesterday.
And here's a dead simple way to see that data. A bar chart like this instantly tells us a story. XYZ Company's milk is a big piece of the pie, but it's not the majority. This is a clear, factual summary of what happened. It's that first step of turning raw numbers into an actual insight. And this right here perfectly illustrates the point. The statement, 30% of milk cans sold were from XYZ Company, is a textbook descriptive statistic. It's a simple, verifiable fact that comes straight from the data they collected. It describes what has happened. No guessing, no predicting, just the facts.
Okay, so we've mastered describing the past. Now let's grab that second and frankly more powerful toolkit, inferential statistics. This is where we make the big leap from describing what we know to making educated guesses about what we don't know.
The whole idea here is leverage, right? It's often impossible, or just way too expensive, to study an entire population, like every single potential customer in the country. So inferential statistics gives us the tools to study a small, representative sample, and then use that data to make a really reliable guess about the entire group. Okay, so this is a super important point, the difference between a statistic and a parameter.
A statistic is just a number that describes your sample. A parameter is the true number you're actually trying to find for the whole population. So what we do is we use the sample statistic to estimate the population parameter. This is the engine behind things like political polls and market research. They talk to a small group of people to infer what the entire country is thinking.
Let's just walk through how it works. First, you define your population. Let's say everyone in Hartford County. Second, you pick a representative sample. Now this part is key. It has to be random, so it accurately reflects the larger group. Third, you go out and test that sample. And finally, this is the magic part. You use the data from that small sample to draw a conclusion about the entire county, and you always state how confident you are in that conclusion.
Let's apply this. So, a health department wants to know the rate of high blood sugar in Hartford County, which has about 100,000 people. They can't test everyone, so they test a random sample of 1,000 residents. In their test, they find that 17% of the sample has high blood sugar. That 17%, that's their sample statistic.
And now they can make an inference. See, they can't say with 100% certainty that exactly 17% of the whole county has high blood sugar. So instead, they make a statement based on probability, just like this one. And this is an incredibly powerful statement. It takes a small result and turns it into a confident estimate about a huge population, giving those public health officials the data they need to take action.
All right, we've looked at both toolkits. Now we get to the most practical part. How do you know which one to use? It's all about matching the right tool to whatever it is you're trying to accomplish. Think of this table as your ultimate cheat sheet. Just ask yourself, what's my goal? Is it to summarize data I already have? Go with descriptive. Is it to predict something about a bigger group I can't measure? That's inferential. What do you want at the end? A simple chart or an average? Descriptive. A probability or a confidence level? That's inferential. This framework makes the choice clear and logical every single time. So, we've reached our final section. Let's boil everything we've talked about down to its absolute essence. This is the one core message I really want you to take away and start using in your work.
Whenever you're staring at a data problem, this is the very first and most important question you have to ask yourself. Is my goal here to accurately report on something that's already happened? Or is my goal to use what happened to make an educated guess about the future or about a much bigger group?
Answering that one question correctly immediately sets you on the right path. It stops you from using a simple average to make a risky prediction, and it stops you from overcomplicating a simple reporting task. Master this distinction between describing and predicting, and you will fundamentally change how you work with data. You'll go from just spitting out numbers to telling a powerful data-driven story.
So I'll just leave you with this thought. Right now, inside your company, there's data just sitting there, waiting to be understood. Is it waiting to tell a story about what has already happened? Or is it waiting to give you a glimpse into the future? Well, now you have the framework to go and find out. Thanks for tuning in.